Okay, welcome you all to the lab section. I have already shared the description. I will go through that now shortly. Before that, I thought I will explain you a few more things using Spider before we get into the exercises. So let me open a new file. Okay, I have to explain a couple of things before we start the lab. Let me first take a few things. Okay, now let me first summarize what we did last time. So what were we seeing today, last class, was to use NumPy to generate few data types, okay? And then I explained how each data type differs from each other, how many bytes they occupy, using some built-in functions of NumPy. So all these data types are supported by dtype class, and we create a particular data type, maybe int or uint, c, something like that. Okay, we create ubyte. We saw quite a lot of data types yesterday. To do the exercise today, we need to have two more data structures. That is, what is the string, how strings are constructed. There are two ways strings can be constructed, using some ASCII encoding, which is a 7-bit encoding, or Unicode. Unicode, as I mentioned, it has got different versions, UTF-8, 16, 32. The names signify that it is a 8-bit encoding. This is actually, it says UTF-16, but it involves two UTF-16 code, which actually takes around 21 bits to encode UTF-16. Okay, 21 bits. Now, what are these encoding? As I mentioned, for different languages, different fonts are there, characters are there. We need to encode them so that the computer, when we are displaying a character, it should know what is the format, what is the font it has to give. Suppose a character A has to be printed in a maybe take a 4x8 pixel grid, suppose like this. Sorry. If you want to write a on the pixel grid, you need to enable such a so many pixels to get a letter on screen. So this printing this particular font for a particular character is taken care of by the display driver, based on the display what you have, as well as the mapping of these pixels. If you have, whether you have chosen 760 by 890 whatever, or you have chosen a high definition screen, then based on the number of pixels there and then the font size you have, this A will be expanded like this or maybe printed like this. It could be anything, but the character A has a particular code which is only stored in the computer as a program or as a string when you are typing it. So that code can be ASCII if it is only you want to print only English letters. But if you want to print UTF-8 or so many other languages, the world has thousands of languages. So if you need to print all those characters, we need different coding. Encoding has to be done. That kind of wide number of encoding has to be done. So it has to be across the world uniform. Then only what you print as a French letter, a sentence, will be seen by everybody in the world as a French character. So there should be a common encoding for that. So that is how these standards have come up. UTF-8, 16 and 32, they are all evolved encoding. So that this ASCII 7 was not sufficient because it can only support 255 encoding, and in this also you have alphabets as well as other control characters like a carriage return, line feed, blank spaces. Those things also need to be encoded in the ASCII. So what has happened is, on top of ASCII, the coding has started off adding more languages so that we can support universal encoding scheme, that even if any new languages come or new characters come, emojis, whatever you see, they all fall under this encoding business. So finally they are all to be encoded into some numbers, and it will be interpreted by the display driver to show it on the screen. Okay, so now to come back to our thing, we have in Python, we have a way of storing the string in either in terms of ASCII character, which will take only 1 byte per character, or if you follow a Unicode character encoding, then it has to take care of this 21-bit of encoding to be done on UTF-16 or UTF-32. Both are, what happened is, if you use UTF-32, it will take 32-bit of encoding, whereas if you use UTF-16, it needs 21 bits of encoding. But since all the registers of CPU are all 32-bit wide, Python went with UTF-32 encoding, okay, for Unicode. And for a normal string, it will be a single byte encoding. Okay, so UTF-32 encoding means every character occupy 4 bytes of data. That much you should understand. So coming back to our definition, now we have np.dtype. So dtype is the built-in data type class. We want to create a string. Okay, now what is this S1? S1 is let me explain. There is a single character in this is called character code. Okay, instead of writing float, you can write F. Instead of writing string, you can write S. Instead of writing Unicode, you can write just U, capital U. So this is one character code to mention what type of encoding has to be done in building the string. Okay, so how many bytes you need for that. Now what I am trying to do here is, in this line, I am trying to define a definition. It's like a type def in C. Okay, type def. I'm defining a type, saying that I want to define a NP type. Okay, I have given some name to mention it, like this is a NP type of just a string, which means that it's ASCII string, a definition. Now definition using NumPy, dtype. Dtype is a type. Okay, this is a type what I am trying to define, one character built using string, ASCII character. This some name has to be given. Okay, ignore this particular thing, but to take care of the convention, I will tell you the reason why this is there. Later on, it will come. You will become clear. A dummy name, and then yes is the indication that I want to build ASCII characters. I want only 1 byte of data to be reserved for one string, one character. String is a string of characters. Okay, and this one means I want to reserve only 1 byte. I can say 2 bytes or 3 bytes or 4 bytes also. Then I will have that many bytes of characters I can store in this particular definition of this type. So in this type, I can only store 1 byte. So I am writing S, which is to mention that it is a ASCII encoding, and I need only 1 byte of ASCII encoding. So I am writing 1. Now I am just only defined a particular character type. I need to create now an array of things using this definition. It's like array of characters or array of float. I can have an array of this type. So, and while creating, I want to initialize it with zeros. Now what I am interested is only once I want to see that only how many bytes it occupies. So I want to create an array of 1 element. So 1, and then type, I want to use my own definition, not the NumPy definition, my own definition, what I have given, saying that it is taking 1 byte, length of 1. So this is also definition also takes 1, and I want to create only one element of that type. That means I want 1 byte to be reserved for a NumPy element np cap. So if I just print it, I will say I will get it size as 1 because only one element is there. Item size, okay, item size, sorry, size is, I have not printed the size now. Item size only I have printed. Okay, so maybe I will say that item size so that you don't get confused with the size of array, or does it mean, so item size is 1. That means that one item in this array which is filled with 0 is having only 1 byte it occupies. And when I print the value, because it is a string, it's a null string, there is nothing to be, because I filled it with 0, it is nothing to print. 0 is having no valid encoding. So it is printing null string. Okay, only 1 byte is reserved, that's why it is showing B. Okay, now let me show you, if I need a Unicode type, what do I do? Okay, suppose I don't want a ASCII character, I want to use Unicode encoding, then what do I do? Same thing. Okay, D type, I am saying use string, I am having a string of Unicode characters. Okay, string of Unicode characters. That also I want only one Unicode. Okay, as I mentioned, it is a UTF-32 encoding, so it will occupy 4 bytes of data it needs, space it needs. Now for a change, I am filling it with ones. Okay, I can also fill it with zeros or ones. Then definition, I am saying this definition, you take this definition and make an array of one element. This I am giving only one element, so make an array of one element and fill it with 1. Okay, and I want to see how many characters it takes. Here also let us print it as item size. Now if you print it, it takes 4 bytes. As I mentioned, it is following a UTF-32 encoding. So for every character, even for printing 1, even though the encoding for this is occupying only 7 bits, lower 7 bits, because it's ASCII value, because ASCII values are mapped. Okay, all the ASCII values are retained in the UTF encoding also. Okay, remember that it is a superset. UTF-32 or whatever is a superset of ASCII. So it follows the same encoding of ASCII. So, but it occupies 4 bytes because it is following Unicode method. So it follows Unicode encoding. Now if you see that it prints Unicode underscore here, whereas what I have given is a capital U here. This is the another way of informing the NumPy, saying that I want to follow a Unicode type. Okay, that's all. So I hope this is clear. Now our job is not done yet. This we have created string of either ASCII characters or a Unicode character, but now I am interested in, similar to a structure, I want to create a data type. Okay, this is a type def we use in C, sorry, capital type def we use, similar to type def with a different types, float, int, character, array. Okay, we want to have a multiple elements in a structure, similar to a structure in NumPy. Okay, we want to do it in NumPy. That is called structured data type. Okay, now structured data type, we can have our own definition. Okay, there is nothing called NumPy standard definition, because it is like this. Now structure is our own wish. What you want to put inside is our own wish, but what you put inside has to be one of the basic data types. Okay, it can be an array of basic data types also, or a single element also, but you can have a structure with the basic data types. Similar to that, I can have a definition called a structured data type with multiple basic data types that I explained to you so far. Okay, in the last class as well as today's class. String also can be a part of a structured data type. Now, how do we do this? Okay, that is what we need to see. I am going to show you that portion. Okay. Now let me take this also completely. I am copying all this because I have written some links as well as some comments which will be useful for you when you are reading through it on your own. So now let me explain this. Understand it, it looks a little bit confusing, but once you have the hang of it, you will be able to define your own structures. Okay, here I am not defining a structure now. I am just showing you with a raw element how do I create a structured data type. Okay, after that I will say definition. Okay, so now I am trying to create an array with specific values. Now what are the values? I want to give an employee name as a string, and then I want to give the number of some number. Okay, it could be, this is age. Okay, I want to give a age of the employee. I don't know, it is I should not give 11, then it is illegal to, child labor is illegal, so let me not put 11 there. Okay, now it is illegal. So we have an employee with the age. What we do, if you want to create a structure, give the actual data that you want to initialize it with. This is one way of doing it. Okay, if you are creating a huge number of arrays, you cannot do that. But if you are just initializing only 2 or 3 elements, I can give the data also along with that. So right now I am showing you how to create a structured data type having multiple basic data types in it, and it is of type NumPy, and I am creating an array of that type. Okay, now I have the employee name and then the age and then another. So now number of entries I give decide the size of the array. Since I have given only 2 tuples, I am indirectly saying that this particular array is going to have only 2 elements, and each of those elements are going to have 2 data types. One is of Unicode string. Okay, Unicode type string of length 10. If you remember earlier, I put 1 there. If you see, I put only 1. I thought I wanted only one small character to be stored there. Here I want 10 of them, 10 of Unicode characters. Now you can imagine I am reserving a 10 locations of 4 bytes each. Okay, for the name, one particular name. That means if I have 2 entries, I need 80 of them. Okay, fine. Now what is the age? Age is the next element, which is data I already given. What is the age? 22 and 33. That is a element. It's like a structure. Within the structure you have a element type in C. Similar to that, I am giving a name to a element inside a structure. Okay, now you will understand why I was using that kind of a definition there. So here I am saying age, as I mentioned, we don't need a huge space. So u byte, because unsigned it is going to be, age is not going to be negative. So I am happy to have, or I want only this much. Okay, 255. I'm not expecting the age to be more than 255. So I am happy to reserve one unsigned byte for the age element. So what I am supposed to do, I am supposed to give the number of elements as the actual data in a list. Okay, this is a Python. Okay, please remember this is all handled by the Python interpreter only. It is fed to the NumPy's library, but what is running all this is Python interpreter. So the definitions are correct and valid. It is all list element with tuples having 2 elements. One is a string and one is a some integer type, integer object. Okay, because it is in the Python world now. It is yet to create an NP array, and then I need to say what type they are, because Python, when it is passing it to a NumPy library, it has to say each of the element how much space I want to reserve. Right now maybe employee name I have given only this much, but later on I may have to write a huge number of entries. So I should decide as a developer how many characters that I expect the name to have. In this case I am thinking that only is not going to be 10. Okay, just for the computation purpose I put 10. Okay, so I am saying the name entry maximum I can have 10 entries, 10 characters of Unicode encoding, and then age is of only byte, so I can have, I'm reserving only 1 byte. Then I am saying you create an array. Now it will create an array of type NumPy because it is internal to NumPy. So it will reserve based on the size what you are given. It will reserve a contiguous memory and then give the reference to that somehow out. Okay, so we get a contiguous memory reserved for the 2 entries of this. Now what I want to print it now. I want to say what is the type of that what I have reserved, returned, what I got, and then what is the size. Now this size says the array size. Okay, it doesn't show you because it is an array of elements. So number of entries it will give. Okay, and then strides I mentioned it already earlier. Okay, let me first print it before I explain to you so that you can have the value also here, so you understand better. Now this is the entry, this is the output we have got. So let us only look at this output. It is 2 entries we have created and it says 41. Let us understand this 41. Now let me take out this. Okay, now why is it 41? I don't know whether by now you might have computed it yourself. See, it is having an element called name of 10 element individual characters, and each character is of Unicode type, and I said that Unicode is following UTF-832 which is needing 4 bytes. So I need 10 elements of each of them taking 4 bytes of memory. So how many you need for this name element? We need 4 into 10 because I have given U10. Okay, U10 I have given. So it is 4 into 10, 40 bytes I need. Now what about the age? Age is a U byte. That's all, only 1 byte. So age is going to occupy only 1 byte. So 40 plus 1 is 41 bytes it is going to occupy. That's what you see as a stride. Why it is called stride? Because stride is something when you have an array of something. Now array of structure, this structure is nothing but NP Emp data. Okay, it is a type is NP Emp data. Is actually Emp data has a complete array. Okay, I am not definition I am not given, so it is a complete array. So but I have given each element here 1 and 2, so each of them are going to occupy 41 bytes each, and then 40 bytes are reserved for the string, name string, and then 1 byte for the age. Okay, age, this is for name. So this is how the contiguous space is reserved. So this is very strict, it will not go beyond that many bytes. Okay, because finally this is going to be executed by the C code underneath in the NumPy library. They are okay to have a very compact contiguous memory structure so that it is occupying less space in the memory, as well as it will be faster when the C library is working on this array. So this is how it is stored internally. Okay, so what you see here 81, 41 is a one particular element size. So you can easily say that stride is actually giving you the size of one element in the array, and 82 is double of that because I have given 2 entries here, and I am printing this data employee name, age 22 and 33. Okay, I hope this is clear. Okay, is there any doubts on this? So because this has to be very clear to you. I hope no doubts on this. Then let me proceed further. Okay, now how do we create a structured type like what we did for our employee data? Okay, now let me open this. Okay, sorry, I want to print a few more data about the employee so that I will tell you how to access individual element so that you get a better idea of how to access the individual element in the number array. So you know very well there are only two elements here, so I am accessing it as a 0 and 1. So the 0 should print, as I mentioned, this NP Emp data is a complete array what I have created, 82 bytes of array. I am accessing 0th element means it is going to print only this much of information, and then one first element, that's in fact it is second element, index 1 is going to print that thing. And then if I want to modify now, okay, I have to take care that I don't exceed the 10 characters. How many are there now? I think it will accept it, maybe, I'm not sure, but let us maybe I will, we have to check it. I will do that. Okay, now I am just changing this element content to something, and what do? I am changing the 0th element and the name of the element. It's like a dictionary. Okay, you can access it as a dictionary. So 0th entry and name element in the 0th entry, I am changing the string, and then I am changing the age to 111 and then printing it again. Okay, and this is not needed, it's not relevant for this particular exercise, so let me print it. Now you see here the name is changed. Is it correct? Am I getting anything wrong? Okay. Oh, order is yeah, correct only. Yeah. So this is the last two entry printing. So I change the name and I am getting it here. Okay, 111333. So I hope this is clear to you. Okay. Now let us do the definition of what I mentioned it, what is required for our exercise today. Okay. Now this is the, I want number of employee to be a okay, before I go, let me explain what I want to do and then we'll come back here. Okay. I hope there are no questions so far. Okay, now let me explain what I want to do it in the class, in the lab today. Then we can start off with the implementation. So what I want to do is define an employee structure called np data def. Okay, with the following fields similar to type def in C. I want an ID, employee ID, which should be unique, ranging from 1 to 2 power 32. I hope now you understand. Okay, I should not say 2 power 32, then minus 1. Okay. Okay. Employee ID, I want maximum should be within this range. I'm okay if it is within the range, because I am not expecting my employees to be more than 4 to the power of 10 power 9 employees. The whole world has to work for me. So max ID is this much. Okay. Name, I want maximum 64 characters of single byte ASCII characters. I don't want to reserve Unicode because I am expecting only English names to be entered. So I'm happy to have ASCII characters used for the name field and maximum of 64 characters. I don't expect the name to be more than 64. Age for my company employees is 20 to 60. So beyond 60, they will be fired. So I'm okay, or not fired, retired. Height of the employees I want to capture because my company job involves something to do with the height of the person. So it should not be like a airport, air hostess. We need some height definition they'll give. So 150 to 180 centimeters. I don't know really it is to within, you will find somebody human being with this height or more than this, I think. I just gave some number, okay? It's centimeter units. So these are the information I want to capture for every employee of the company. Now, I want you to be very careful in choosing the right data type, because you know that the employee size could be huge. So I don't want to waste my bytes in the data, not too many things more than what is required. And then I want to create an array of this type of length num employee. Okay, this is another definition. Nump employee, number of employees in the organization. So you can in fact modify it to see the performance of the implementation, Python implementation and NumPy implementation. So that's why I want to put a variable here. You use this variable only to define all the functions that you write, accessing the array, going through the array. Everything should be based on this variable name, variable value, because I may change it and your program should work for any number of employees in the organization. So you have to define one Python variable. Of course, it will be in integer, and it holds number of employees in your organization. You may be required to make it as huge as possible, because it is not going to be a NumPy element. It is an integer object of Python. So you don't need to worry about the size or anything, because it's only one entry. So no problem. Don't worry about optimizing this value. You have to optimize only the array, because that is going to hold data of all the employees. But here I am going to create one integer object to hold the total number of employees in the organization. So you can use the integer variable for that, Python integer variable. You need to write few functions assigning employee name. Okay, I will tell you what name to be assigned randomly, not randomly, some specific name. And the employee ID has to be unique, starting from 1 to maximum, whatever is given. And then you need to write a Python function to assign the employee age. When you assign, means you are assigning for the whole, all the entries. Okay, don't think that you are making an entry for one particular element in the array. For all the employees, you will create as many number of entries as the number of employees says, and then you will start calling these functions. You write it as a function, pass the array into them, and you should initialize all the entries that you have created for the employee. So age you have to enter. I will tell you what age to enter, and then employee height has to be entered, and then you have to write a function also to find the average of both age and the height. What is the average age of your employees, average age of the height of the employees in the organization. So these are the things you need to do. You need to write Python function as well as using NumPy. Okay, let us come to that now. Now, how do you define a structure? As I explained earlier, what we do, we are defining a structure type of NPD type. It's not an array, remember, it is a D type. I am giving a single list with all the elements that needs to go into the structure. Okay, I am having an element of ID. This is a name of the ID, that element in the structure ID. Another one is name, to hold the name of the employee. This is to hold the ID of the employee, and age of the employee, and height of the employee. This is a one structure type. Now ID has to be of type uint. Okay, unsigned integer, because ID cannot be negative. I am expecting it to be 1 to 32. So uint will actually, on this machine, will give you a 32-bit value. So uint is fine. So np.uint. Name is the element's name, not the actual name of the employee. Is a element name of S type. S means it's a ASCII character, single byte characters. I want to reserve 64, because the requirement said that 64 is the maximum limit. So now the name maximum can go up to 64. So I want to reserve 64. Age is of U byte and height is of U byte, because the range I gave you can be accommodated within a U byte. because 180 I gave you. If you put byte or a sign byte or a int 8, if you put, it will not be suitable because height can go up to 180. So u byte is very important. I have given you the things here itself. I want it to be zero field, so you have to call it as np.zeros after creating the array of this type. Okay, how do you create? Np zeros, number of employees, that many entries you want to create, and the type is of this type. So it will create number of employee, number of elements in an array of this type. That means it will reserve elements, all 4 elements it will reserve space for, and then it will fill it with 0 and return the structure to you. Okay, it's a byte contiguous byte space. Now what you should do is, using this array, you have to now fill the element. Okay, Python code you have to write, as well as using the NumPy function. I will tell you what function to use. Now fill in unique employee IDs from 1 to whatever number of employees, and then fill in the names of the employees as name 1, name 2, etc. Age, I want you to randomly choose between 20 to 60. Okay, that you can use the np function only, np random.randint. You can say what is the seed, starting seed, and then high value. It will generate within the limits. It's inclusive on both sides, so it will generate some random integers within the limit. Height is also you can generate like this, and then find average. You write a function find average. Now you need to write NumPy using the NumPy library also, which is np average. You need to pass the array of age. Okay, age elements only. Okay, it will internally, because it is a np array, this function knows how to access only the age elements within the array. So it will find the elements of age, all the ages of the employees, and then find the average and give you. Similarly, height. Now I want you to compare the time taken by both by using this import time and then time process time nanosecond. So it will return the value number of nanoseconds taken to get the timestamp of before and after the function is done, both for Python as well as for the NumPy libraries, and compare the values. Okay, this is what I want you to do. I hope this is clear. And then initially, how do you do it? 4 you create, and then 4 or 1 element, and then try to find out the average and verify yourself whether it is doing properly or not, and then add the performance metrics. Then initialize the employee with the 0 first, and then actual data, call the functions, and then do it for higher numbers and see the difference in the performance of Python as well as NumPy library. This is the job to be done. Now to make, I hope this is not a very difficult problem, as I mentioned. Let us look at the solution directly. Okay, before I run it, do you see a major difference in terms of performance between your Python implementation and the NumPy implementation? Okay. Okay, very good. Processing time difference is this much, is it? Okay. Oh, you are printing it for every run. Maybe at the end you can. Okay. So this is the difference in terms of one computation. Okay. Time taken. Okay. One more thing, Rohan, maybe you can try running it again. Sometimes I don't know still this why is this showing 0 sometime, and then gives you the next run, it gives you the value. So run it again, you may see a difference, but maybe you will have a major difference. Yeah, go ahead, Sandeep.
Sir, when you say difference in what terms? Because what I have done is I have simply changed the value of number of employees and have run all the functions that you have mentioned. and the processing time is the difference between the end time and the start time. So how do I compare it with the normal Python program?
Oh, okay. So let me explain what I wanted you to do. Okay, see what we are doing is we are doing some initialization. Okay, that we are doing it in Python. Okay, that also we can try to do using NumPy. I don't know what you guys have done. I did it using Python only, and after the data is initialized with all that employee ID, age, and then height. Only what I wanted to time it is only finding the average. Finding averages, only this function I wanted to find out what is the how much time does it take. So before I call the Python code, I said start time, end time, and then measure this time t1, and then use the np dot average dot that array. Okay, and because you are doing it twice, you can put both of them one after the other, and then start end. So how much of this, finding the average of the entries in NumPy, because we are doing this only in NumPy, the average computation. Whereas other things, though we have implemented the array in NP array, we have used the NP array, we have we are using the Python code to do the thing. Okay, the functions are all Python functions. So only this average finding out, I wanted to do the timing, not including the init and all that. Okay, this initialization, anyway you are doing it in Python only, we are not doing anything in NP NumPy library. So you just compare the time for this function and the computation of two averages, see whether you see a major difference. Okay, that's what I wanted to do. Anyway, no issues. Even if you are not done now, you can do it later. And okay, more importantly, number of employee, you have to change it on every run, maybe with a few numbers, and then keep increasing it to maximum, and then see the effect. So then only you will see really the NumPy stands out very nicely. Okay, let us see that now. Anyway, this is what I did and I wanted you to do. You can do it later also. So this is the code. Let me run it once first. Oh, sorry, not this code. Where is it? This is the code. Both are 0. Oh, okay, I have put a very small number. So let me make it a big number. It may take some time for that to initialize and run. It's okay. So if you print after all the assignment of IDs, you should get this ID. That means you have really assigned all the increasing order of IDs, unique IDs to employees. If you are getting it one more than this, of course there won't be any mistakes in this. Okay, let us, while it is running, we will see the implementation. It's not very difficult. Okay, first definition. What video? I have already shown this definition anyway, nothing new. Okay, let us see the difference. Oh, it's not come out. It is printing very slow. Okay, so this is the difference. This is the time taken for computing the average using the Python function, and this is the time taken for in nanoseconds using the NumPy, and the values happen to be same. Okay, of course that matches both, and then the difference is this much. I saw that it's around 48 times or 50 times the difference. Okay, for the when the size is of how much, 5 million. Okay, 5 into 10 power 6. Okay, now let us quickly look at the implementation. Assign employee name, very simple. You pass the array and then access this as a global variable and use it as a range. And what I assigned is x plus 1. Okay, that you need to take care that you assign from 1 to the number value, because this range will give you one less than the value, things. The number actually, it will be 0 to num m minus 1. So you have to add 1 to it. Then you will get the name initialized. So every entry, what you are doing is you are accessing it with using this, and then initializing the name entry with the name 1, name 2. Then after that, employee ID, maybe these two could have been merged because I am not doing it efficiently. We can actually, all of them can be merged actually. You don't need to as a function, but just to, because we might change the individual logic for any of this. That's why I made it as an individual thing, because the logic what you use can be different, but actually implementation should have been one function. Okay, because we are iterating over a huge number of things multiple times, which is not efficient. That's why it is taking so much time. We could have done it in one for loop, all of them together. Okay. I am not saying that this is the most best way of implementing it. It is not. Okay. So just for clarity, I have put it as separate. So don't bother. Our aim is to only measure the time of average. Okay. And assign ID is nothing but just take the current ID and then put it inside and keep incrementing it. So you have to maintain as a global and then keep incrementing it. You may wonder, why am I doing this? You can in fact use this x only to assign it. The problem is, suppose this function is called after a few times, you keep adding new employees, you will lose out the number of employee IDs you have assigned to already. Okay, how many employees IDs are assigned? You might have created that huge array, but you may not have that many employees to start with. Then you will be adding the employees to your organization. So you have to maintain it as a current ID, so that whenever a new employee comes, you can assign a new ID. So if you have implemented, assuming that X, which is not the right implementation in my opinion, because you should keep it such that you can add as and when the employees come. Okay, it's not that we add it like this. Maybe we may add it later on. So you need to maintain this. Otherwise, you will. There may be some function to get the number of entries, but you cannot find out how many you have entered. You have to again run through the list to see. Okay, so that may become a headache. So you better have maintain one current ID. That will be good. Okay, this is like a design aspects I am giving you, which is bad, which is good. Okay, you might have done something better than this. I am not saying that this is the only way, but at least in my implementation, I am showing you what is good, what is bad. And this I could have done it in the same for loop. I am random int I am calling and then I am assigning it. That's all. So there is nothing great about it. And same thing we are doing for the height also. So all this could have been merged together. And then coming to average. Now, typical way of implementing it, not using the array. Actually, you could have done a Python array implementation, but I am doing a for loop. Actually, it is same. You have to go through every element. So this is actually more time-consuming operation when the number of entries are more. But we keep bringing it to the Python, and though it is a byte array, what you are accessing is a NumPy array. So in terms of memory, you are not actually doing anything great because already you have optimized it by using the NumPy array. But the problem here is using the Python to compute the addition and then keeping the result every time, going therein and then coming again in keeping it in the Python world is actually inefficient. Okay, so that is why it takes so much of time when you do it on Python. Though you are accessing the same array, which is compact in terms of byte also, it is all contiguous space only, because you are accessing those entries which are stored in the byte array only. So in fact, memory wise it is efficient, but the fact that you are going and coming in and then adding it to the Python for loop and then interpreted code you are running here, which is causing the lot of delay here. Okay, so whereas how is the library function makes it faster, very good, very fast. Why? this function NP average gets the array, okay, and based on the age, whatever the element you are accessing, it knows what is the offset, relative offset. Okay, let me explain what I mean by why it is efficient and compared to Python implementation. By now you might have even made understood it, but still for the completeness sake, see, we have a byte array only, and then different structures are there, each employee data. Within that, we are accessing age here, age here, age here. Now the stride between this and this offset of age will be the same. Okay, it will access this and then it will jump from here to here. That offset is also same. So internally, in fact, I can give you an exercise to write a C code for it. Okay, and then if you use, in fact, that is the way to become a library developer of Python. You implement this code in C and use the technique that we have used in the last class to integrate your C function into your Python code. Then instead of NumPy library, use your own function, okay, your own function, C function, implement it as best as possible and compile it using the proper compiler optimization. Okay, then you can compare your implementation of C with the NumPy's library implementation. Then if you do better, in fact, you can write to Guido and then say that I can give my library for replace it with my library because I am doing better than your library. Okay, that you can do in case if you successful in that, because what is NumPy library doing is nothing but a C code. So how is it doing it better? Because it is not interpreted. The addition and then accessing the array is completely done in C, and it may be using some. It is not a string manipulation or streaming functions. It might use. We don't know. Actually, it can use actually streaming. As I said, SIMD. It can do because it is doing an addition operation over multiple data. So it can take a batch of data and then add it. Okay, 100 data, or suppose you have a ALU, multiple ALUs in the processor, maybe 24 ALUs are there. It can take this 50,000 data where it knows fixed offset it is there, the age values, it can add all of them together as in bunches in terms of 24 each, because ALUs 24 ALU hardware are there, you cannot parallelize more. But if you do the addition in parallel using some specific assembly instructions of the processor, which they may be doing it, it will be better than your implementation, because you will be doing only in C, but they may optimize it even further by doing this. And because multiple additions are done, it can be done using the SSE instruction, and then finally they divide it, integer division or a floating point division, and then find the actual average. Okay, so that's how you are getting a much better value compared to what you get in the Python library, Python functions. Okay, this is how you are improving it. I think that's what I wanted to explain. Is there any questions on what I explained? Do you have any doubts? Uh, I don't know whether I answered your question, Rohan, already, or you still have the doubt. Yeah, of course. NumPy is how much faster than Python code? Oh, okay, not understood. Okay, let me explain further again. Okay, see,
Sir, I meant it's clear.
I'm sorry.
Sir, it's clear, sir.
Oh,
What you
clear. Okay.
explained.
Oh, sorry, I didn't read it. No,
Sir,
sorry, I understood.
Sir,
yes,
I wrote it.
sir, I printed the NumPy time and Python time in the ratio. Normally,
Oh,
it is 10 times faster. NumPy is 10 times faster.
10 times only? No, man. I saw
Yes,
some.
sir.
I saw something better than that.
I have
See,
printed what I have.
see here. This is the number I am getting. Uh, okay, you guys verify whether I am typing properly. 9156251234 divided by 46 87530. Huh? I am getting much bigger number. I thought I saw 50, but now it is showing 195. Maybe number of entries are more. I am getting this much, right? This is the number of nanosecond cycle, number of nanosecond. So you have to divide this number by this number, then you will get how fast it is, right? Am I doing anything wrong?
Yes, sir. What I basically did was, after getting what I'm just dividing Python time by the NumPy time,
Yeah, correct.
and it
So,
is and the results are same on my laptop also and on the online compiler also.
why?
Should I
Okay,
share my screen?
yeah.
Yeah.
Okay, Aditi is getting a better number. You should see for the huge number of employees, then only the improvement will be better.
Okay, sir.
How can I make your scene only bigger? Okay.
So what I have done is,
Uh,
uh, I have just iterated the value of n from 5 to 500,
uh,
intervals of 50. I've just taken name calls and I'm just multiplying it with a namesake. And
oh,
then
okay, actually I can't read the code because my eyesight is bad and it is very small in my screen as you see.
okay, I'll tell you in short.
Yeah,
Uh, Basically, what we are concerned is with this with two functions. One is the find average, which is nothing but what NumPy runs.
correct.
The NumPy and this NumPy average AVG. This second one function is nothing but I'm using the loop, normal loop,
Mm.
and then calculating the value, storing all the heights in S, and then dividing it by the number of employees. So
Yeah.
this one is the average, and this is the height.
Mm.
And then what I'm doing is I'm storing the start time and the end time, and then I'm printing the Python time. Same I'm doing with doing this in find average also, start time and end time, and then I'm printing it, and then I'm returning these two values.
Okay.
Where I'm returning here T1 and T2, and then I'm just dividing it T2 and T1. Yeah.
Okay. So how much are you getting? Value you said?
Normally it is, sometimes it is 9, sometimes it is 10, but it is hovering between 11, 12, 11, 12. Sometimes you can see for 405 it went up to 30, but normally it is this.
Okay. You are running it on your laptop or on the Collab kind of a thing?
I ran it on my laptop, and
Online.
while you said that it is over 30 or 40, I copied the code and ran it on online compiler also. It is showing the same.
Okay, see, you may not get much of improvement on online because it is running on a virtual machine. I'll tell you where it may not be very as efficient in the online. What happens is they create a VM, normally Linux VM, and then that is what Collab does. Okay, I don't know about what online compiler you are having. That online compiler normal thing. It may also be doing this. Okay, so finally they may be having a server. No, which is shared. Okay, multiple users will be sharing it. So there may be a lot of delay in terms of executing it on the CPU, and then there is a hardware layer, and maybe guest OS will be there, or not host OS, whatever the original OS, and then Linux OS. So there is a lot of conversion involved. So online may not get a better improvement, okay, in my opinion. But you should see a better improvement in your laptop. I hope your laptop has at least iCore 7 or something. In that case, they will have the SIMD extension. And which are you using Spider or some other IDE?
Sir, so my laptop is i3.
Okay.
And I'm using VS Code. Clearly, as you said, that it depends on the laptop. Maybe because I know that Aditi has bought a new laptop. So does GPU matter in this case?
No, GPU is not needed. Okay, we are not doing any major operation, but within the CPU itself, okay, the high-end CPUs have a SIMD instructions. Okay, this is like Intel's normal extension instructions are there, and then they have a hardware accelerator, which is a SIMD thing, wherein they have multiple MAC units. Okay, multiple ALUs they have, and then there is a separate instructions which is called SSE, or even the advanced version is there. I forget the name of that. Something next version of SSE. So what happens is, if you are using a latest compiler, and it depends on the compiler also. Okay, the Python interpreter what you have, and the NumPy library you have, and in which version of the IDE, whether Spider or whether you are using what IDE. So all of them put together makes a difference. Okay, what they finally generate the code, and whether they do a hardware assembly, optimization or not, it again depends on NumPy implementation is one, and the library implementation is on that particular architecture is different. So it has multiple variables. So mainly hardware has to support. Otherwise, what will happen is, suppose if you are running it on a normal CPU, it doesn't have that SSE support. Then what happens is, the generated code may have SSE instruction, but they will not use it because this CPU does not support it. There will be a if condition whether SSE support is there or not. If it is not, they will run the normal code which is run on the CPU, normal CPU execution. So it will be much lower than what you get in a CPU with a SSE optimization. But GPU, whether they use it for this purpose or not, again, I don't know. It depends on the tool whether they use the GPU for this, because they can do always use the GPU also, even for addition operation. But the thing is, here we are doing integer addition. Okay, it is not a float. So what you should do is, you should change maybe the height and everything to float, and then try to compare the values. Then you will see little bit difference in terms of whether GPU is there or not, and the tool is using it or not. So there are so many things. We have to observe what you see, and then try to reduce the reasons. Okay, I hope you understand what I'm saying. Okay.
So yes, sir. So what processor are you using? What is your what is that i3, i4? I'm using i3.
Okay.
Maybe it depends on the processor, I guess.
Sandeep, actually it depend on the generation which you have. I posted in the chat. Please verify from there.
But I cannot understand what it means.
Just go to the properties, and when you see the sir showing i7 1065 means he has 10 generation processor.
Right.
You can check on the PC configuration, and whatever the leading number after the I processor is showing is the generation.
System info you can see, and then 4 cores, and I have even this makes it may not make a difference, because finally our Python will be running it as a single core, but it might create multiple threads to parallelize the thing, but that is more unlikely in my opinion. So even if it have a 4 cores, that may not make a big difference here, but it has a GPU. Where is it? GPU support, is it shown here? I'm sure it has a GPU, I think. No? Guys, can you see anything GPU coming here? May not be. It doesn't have. Okay. So,
sir, you can check in the task manager.
We can check here also, right? Components. No, these are all.
So it is very tricky. Or you can go to the direct text diagnostic tool via run.
What is that?
DXDIAG.
DXDIAG.
AG. Yes, sir.
No, it doesn't have.
Sir, please click on yes.
Okay.
And the second tab is display. You can check here.
I don't think it graphics. Yeah, plus graphics. I think it is not a.
Yes, actually it is a sir working graphics. If you have a dedicated graphic card, you can check via pressing Control Shift and Escape through the task manager, and there in the performance tab you can check either you have the dedicated one or not, the dedicated graphics or not.
I don't think I bought it anyway.
Yes, sir. In performance tab. Here you can and scroll it down. There is GPU 1 and GPU 2. You have NVIDIA graphic card.
Yeah, NVIDIA is
MX230 very basic graphic card you have.
Yeah.
But you have a dedicated one.
I think there is one Intel's one and then NVIDIA's one, right?
Yes, sir. Integrated is Intel and dedicated is NVIDIA.
Dedicated, yeah. Two are there. So it has come with this model. Actually, I have. Yeah, NVIDIA is there.
Sir, by default, if you go with i7, in nowadays they are bundled with default dedicated graphic card like MX230 or any GTX series graphic.
Yeah, I have my sticker also. NVIDIA sticker is there on my laptop. So I forgot to tell you. Okay, good. So maybe it whether it uses the GPU or not is question based on the tool. Okay, this is Anand Jain.
Sir, in order to
yeah, go ahead.
Sir, in order to use the GPU, we have to invoke the CUDA cores, and NumPy itself directly don't invoke the CUDA cores. We have to use TensorFlow or Keras.
Oh, NumPy library will not use directly. You are saying GPUs, okay? But I think SSC implementation may be done because it's a processor thing. Okay, it may not be GPU dependent. So the SSC optimizations it could do. Okay, as he mentioned, these are the processors. I think they support SSC. I think the SSC is a very old one. Actually, you have a latest version of SSC. I forget the name. Next version of.
Sir, you can check on the chat.
Yeah.
I given the link where you can see the latest version and also check the compatible processors also.
Okay, 1 second. AVX, this is what I was mentioning. Advanced vector extensions. Okay, SSC4. Even the number also matters. Okay, whether it's SSC2 or 4. So this you don't need it is built into the Intel's processor, so you can use this instruction. So you don't need a CUDA or TensorFlow thing. But as I mentioned, Manish mentioned it. If you want to use the GPU, you need to have a extension specifically you have to call. Otherwise, it will not be using it. Thanks, Manish. Okay, so I hope you guys understand why we are getting an improvement in performance. So this is answered. So that's what I wanted to show you today.